So now I want to do a final example for you. It says test the relation for symmetries. Y cubed minus y equals x cubed minus x. This is not a function, so we're not going to ask whether it's even or odd. Just the symmetries, which is symmetric in the x-axis, symmetric in the y-axis, symmetric in the origin. Does it have any of those three symmetries or any combination of them? So first I'm going to test to see if it's symmetric in the y-axis. And I would write this out exactly like this. Sim in y-axis, colon, underline, x goes to x, s goes to the opposite of x. So symmetry in the y-axis is the opposite letter that you're changing. X goes to negative x. And then just take your formula and everywhere there's an x, replace it with a negative x in parentheses, right? To make sure that things are multiplied out correctly. And then simplify that, so you get y cubed minus y equals negative x cubed plus x. And you'll notice, if you look at this, the original on the left side, y cubed minus y, I've got the same thing on the left side. But on the right side, x cubed minus x, I've got the wrong sign, right? It's negative x cubed plus x. So these two are not equivalent. You can't, by using proper algebraic rules, you can't change one of these into the other one. And so they don't have the same graph. So they're not equivalent. And that means that this relation is not symmetric in the y-axis. Okay, and then we test to see if it's symmetric in the x-axis. And I would write this out just like this. You know, what I'm doing is I'm saying what I'm doing, and then I do it so I can keep track on my paper of what I've done, what I haven't done, and I can keep track in my mind of what the test is. How does it work so that I'll remember it later? Okay, so I got symmetric in the x-axis. Change y to negative y in the original formula. So I get negative y in parentheses cubed minus negative y in parentheses equals x cubed minus x. And you simplify that and you get negative y cubed plus y equals x cubed minus x. Now we've got this thing where the right-hand side of the original is the same as the right-hand side of my new relation. But the left-hand side is the opposite. And so you can't make both sides the same as the original using proper algebraic methods. So these are not equivalent. They don't have the same graph. And therefore, this original relation here is not symmetric in the x-axis. It fails the test there. Okay, so the graphs are not equivalent to the original. Or the equation is not equivalent to the original, so not symmetric in the x-axis. And then you have to check the third one, which is symmetric in the origin. Now you might think that if it's not symmetric in the y-axis and it's not symmetric in the x-axis, it can't possibly be symmetric in the origin, but that turns out to be completely false. Actually, these three things are independent. You have to check all three of them. You can't get yes or no for two of them and deduce the third one from that. You have to do the test separately. So I'm checking if it's symmetric in the origin. Now how do you do that? Change x to minus x and y to minus y at the same time. Okay, so I've got negative y I plugged in for the y, and I plugged in negative x for x. And then I simplify, and I get negative y cubed plus y equals negative x cubed plus x. Now, if you look at it, the left-hand side of the original is the opposite of what I got. But the right-hand side of the original is also the opposite of what I got. So if I take this equation that I got, negative y cubed plus y equals negative x cubed plus x, multiply both sides of the equations by -1, which is a legally allowed algebraic manipulation, right? I end up getting y cubed minus y equals x cubed minus x, and that is identical to the original formula. Okay, so that means that these two were equivalent, right? So the graph is the same, and that means it's symmetric in the origin. Okay? So the original equation, its graph is symmetric in the origin. Now, just to show you what that means, I'm on the next little video, I'm going to show you the graph of this.